There are only very few technologies that can achieve the scale that we need as humanity. And direct air capture has the potential to achieve really the gigaton scale. So that's why we believe it's the most appropriate thing we can do. Hey, I'm Rene Haas, CEO and co-founder of NeoCarbon, and we capture carbon at scale with cooling towers. There's so much CO2 in the air that we need to get rid of. It's now something which is unavoidable. So it's not an option anymore, it's really something we have to do if we want to have a planet that we can also give to future generations.
So this is our latest prototype, which can capture up to 5 tons per year. So you have the air coming in from that side because there's a big fan here that's sucking out all the air. So then the air goes through this big cylinder there, that's the reactor. Up to 70–80% of the energy we use in the process is actually not electrical energy, it's coming directly as a waste heat from the cooling tower.
The advantage of the cooling tower is more that we say we have a lot of waste heat, which we can use for desorption. We have a lot of airflow, processing ambient air, and we have the advantage of saving a lot of time and money on the groundwork, because half of your plant is already being built. What we are building is special because of the retrofitting of existing infrastructure. So that makes us unique as a company and something no one else is doing in the world. We get the CO2 in a very pure form as a gas or liquid, so 90% plus purity. In the first step, we will utilize it for certain industries, for example, like carbonated drinks, and also utilizing it for greenhouses and so on, before we reach the scale where we do carbon removal and storage. So meaning we capture it from ambient air and store it very long term back underground or in concrete.
It stands at about 2 meter high, 2 meter wide and 1.5 meters deep. It's autonomous, so you can press a button and it runs the whole cycle itself, meaning you don't have to have very wide expertise about how to run carbon capture or what to do.
We solve the problem of the very high costs, and we solve the problem also of the deployment speed. So using something what we already have to perform direct air capture has such a huge advantage also in scale up speed. We are super proud. It's the biggest challenge humanity is facing. There are only very few technologies that can achieve the scale that we need as humanity. And direct air capture has the potential to achieve really the gigaton scale. So that's why we believe it's the most appropriate thing we can do. In our dreams, we would have not thought to come that far in such a short amount of time. Last year, we went to the hardware store and we built a small scale pilot. Now we have already like that machine, and seeing this at the customer side and really running, of course, there will be a lot of troubleshooting, but we didn't dream of that.